Jai Shri Narayan kids, we are going to discuss the 22nd January Shift-1 Physics JEE Mains 2026 paper. Today's paper, the physics difficult. Difficult in the sense you have to solve lengthy calculations, ideas also involved. After long gap, we are seeing physics difficult, chemistry very easy, maths moderate, or you can call easy also. Of course, calculations are there. The maths moderate, your marks versus percentile. 90 marks will be the 92 percentile. Usually, what we can say cutoff. Then 101 marks will be 94 percentile. Plus or minus, plus or 5 minus, plus or minus 5 marks you can put on either way. Okay, then 112 marks will be 95 percentile. 123 marks will be 96 percentile, and all this 140 marks will be 98 percentile. As the paper, overall paper, we can call it to be like a tough. So because of that, what happened, you can expect the 98 percentile at very low marks. 140 marks is what you are going to get it. Then 99 percentile is around 120. Again, huge gap is there. So solving that, getting that 140 marks, and these two were really scoring. The paper should have balanced. Any student who has first took chemistry, maths, then physics, you'll score better. Student who has picked the first physics, then maths, then chemistry, I think score will be low. The choice of paper is very important. Sir, how do I come to know paper tough or easy? That's why what is the best thing is like solve 10 questions from one subject. You feel it's a tough. After solving 10, migrate to other subject. So first physics 10, chemistry 10, maths 10. Then within this, what will happen? You will come to know what are the which subject is tough. The one subject tough, push to the last. These are the some methodologies. What will happen? You have to bring it. So what I mean to say, like a 10 marks, 10 questions you solve physics initially. 10 you solve chemistry, 10 you solve maths. You'll come to know which is tough, no? Then the one which is this is tougher, then again push it to the last. The easy one now you do it. Next the moderate one, next the tougher one. Some strategies you have to plan yourself. Those who are writing the next shifts, please use this methodology. 10 questions, 10, 10, 10. Then with the help of that, you'll come to know which is easy, tough. The one which is tougher, push to the last. Okay, fine. This is the thing. Next, we'll go for the physics weightage. This will be a little bit alarming, like the way they've asked. No? The physics weightage. Mechanics, only 6. Those who are prepared, mechanics more, no? Little bit some troublesome here. LCT maximum, here also 7. Modern physics 4. Experimental physics 1. Waves and sound only 1. Thermal physics 2. Optics 4. These are the unit wise, the questions that are being asked. Then again come for the type of questions. The physics, what will happen there, numerical base as usual 4, which are purely formula. Then in objective also, where if you apply formula and you'll get answer, and there are 11 questions. Together this will decide rank, I think, in every paper. Here these things became difficult. The tougher questions came here. This section. So your entire paper, easy or tough, what happened? This section will determine. And 4 questions of derivation in objective only, where you have to derive, then options will be available. Then 2 questions were conceptual, where objective only, we have to just pick up the suitable options, no? Without any derivations, nothing, analysis you have to do it. Assertion, reason, statement wise, 1 question. Match the following, 2 questions are there. I think the scoring things here, then this particular thing, out of 11, if you're able to solve 5, here 3 questions, here 2 questions, like this, you could have pulled up more marks from here. Huh? Okay, altogether paper tough, and the 98 percentile will be around 140 marks, what I given, plus or minus 5 on either side. So we'll directly go to the paper solving. uh, Paper tough. Okay, some questions where you could have chosen to leave them. And if you spend time more with the chemistry maths, no, the score would have improved a very good. Okay, let's start with this one. This particular question is based on the waves and sound. Waves and sound, one question they've asked, and that too based on interference, similar to like a YDAC concept what we use. Not YDAC, the diagram of YDAC is available here. And this has to be applied here now. Now, okay, we'll solve like this. The topic belongs to waves and sound. I'll switch off the video because I can't. In this portion, I can't write. Okay, fine. Okay, we'll start like this. First one. This question is based on the waves and sound. Then from here, a wave will propagate like this. From here also a wave will come. These two waves, they'll undergo superposition. Okay, fine now. He's asking find the frequency. 10 maximas are form distilling. So it is a path difference is what we'll take in this one. So from the triangle, this is L1, L1, L2. L2B we have to calculate now. This wave, L2B, this will become 40 meter, 25 meter. Distance covered by it. So L2B is equal to root of 40 meter. This will be 15 meter. This length how much will become 30 meter. Sorry, this will become 30. This will become 30. So 40 square plus 30 square. This will become 50. L1B will calculate. Similarly, L1B will be this length. I'll give some other color. This length will be 15 meter. This wave will cover 10, 5, 20 meters. Sorry. This will be some data here. I'll write it clearly for this. This will be 5. This length will be 20 meter. This will be 10 meter. Okay, from mathematics, check it here. Okay, root of 40 plus 20. 20 root 5. Then the path difference delta x is equal to which will be greater 50 meters. So L2b minus L1b. 50 minus 20 root 5. This is a delta x. Huh? From this delta x, we should calculate the lambda. Next is telling on width AB on the wall, 10 maximas and minimas are formed. If velocity of sound is, this should be equal to, how much it should be equal to? Delta x equal to n lambda, 10 lambda. 10 lambda equal to delta x. So lambda equal to 50 minus 20 root 5 by 10. 5 minus 2 root 5. Then f equal to v by lambda. Speed of the sound 324. 5 minus 2 root 5. 324 5 minus 2 into 2.23. We'll get nearest, not exact value. Okay, little bit some very odd way. This based on the waves and sound and interference. This question is tougher. I will take the next question. As shown, 3 coils are given, have equal current in the first and last coil. Choose the correct option for the second inductor to have clockwise current. Based on this question based on the mutual inductance subtopic, and the chapter is electromagnetic induction. Now we have to solve this one. It's telling choose the correct option for the second inductor to have the clockwise current. Directly we'll do one thing. The inductor only will just show like a coil. Paper, white tough means we have to put effort. Clockwise current. So from where clockwise, anti-clockwise. Here anti-clockwise current is there. Himself is telling current flowing here is anti-clockwise. I1. Here current flowing is I2 and you are standing here. Now you move this like this. There is a coil L1, L2 and L3. Let me move like this. One option better to search it. Now if you're standing here, this will produce the B bar. This will produce B1 bar this direction. Current. This will produce B3 like this. According to the Lenz's law, flux phi1. Phi1 is positive. Phi3 is negative. If the flux is into the plane, it will be positive. So here like this. If B bar out of the plane according to this person. So therefore, flux will be positive. According to this person, B3 is into the plane. Because this will produce magnetic field at the second coil in this direction. Everywhere like this. So therefore, flux will be negative. Then, what we do is like, as you move, as the coil 1 is moves towards right, no, this will increase. So D phi 1 d phi 1 by dt should be positive. This will decrease d phi 3 by dt. Negative flux, positive flux increases, positive. Negative flux decreases, will become positive. Sir, what do you mean by this? What you are doing here? Actually, we are doing like this. If this coil 1 moves like this, B1 will increase. Positive flux increases, d phi by dt positive. What about this? Coil 3 will produce B3 bar in this direction. As you move away, the magnetic field strength will decrease here, no? B3. So therefore, the negative flux decreases, d phi 3 bed will be positive. Then EMF induced E1 negative. E3 will be negative. Negative in the sense will be clockwise. If this I1 will be clockwise, current in second coil, I2 will be clockwise and I2 will be clockwise. So now this current should be according to this person should be clockwise. Lenz's law convention I explained. Once you go through my video, you get exact picture, sir. Why EMF induced negative current should be clockwise. Yes, that's what the Lenz's law convention. This is what the option 1 is coming. The other option you verify it will be wrong. We'll take the next one. Find the moment of inertia about given axis of the two solid spheres. Directly you have to apply this axis of rotation. Then you are having two axes. One axis is this other axis about their center of mass. So then what is the moment of inertia? It will be like a Palax's theorem. If you apply it, this will be 2m1 r1 square by 5 plus m1 r1 square plus about center of mass of second sphere. And so on. Palax's theorem we are applying it. Moment of inertia about any diameter for solid sphere, how much will be? 2 by 5 mr square. 2 by 5 mr square. Where these axes will be at a distance r1, r2, m1 r1 square, m2 r2 square. Substituting calculation, paper, very easy, but calculations who will do? You should do. That's why it is tough. Okay. Next, we have the electrostatics. Based on the finding relation between E and V. Subtopic. Relation E and V. So he has given the electric field vector. Potential at this point is asking. You have to calculate the potential at the origin. Now what we should do now this. dV is equal to, what is the basic formula? The basic formula is E bar dot dr bar. Let me call this point as A and the origin as B. So A to B, BA, BB. So this will become VB minus VA equal to minus E bar value. 10x I cap j cap dot j cap. Okay, this will be, what is the position of A? 10 comma 20 0 comma 0. Okay, this will be further VB. VB. VA is how much? 500 minus of 10x dx 5I dy 0 comma 0. So this will become VB minus 500 minus of 5x square plus this will become 0 comma 0 10 comma 20. And this negative sign will adjust for the limits. Okay, now next step will be calculations. We have to be very careful here. This will become 5x square 10 square 5 by 2 20 square minus 5 0 square 5 by 2 0 square. Solving all this, VB will get it as 2000 volt. This is based on the kinematics projectile. A particle is projected at an angle of 60 degree with the ground. When the projectile makes an angle 45 degree with the horizontal, its speed becomes 20 meter per second. Find the initial velocity. Okay, you have to take help of the basic projectiles here. You have projected like this. The particle will move in a parabolic path. Angle 60 degree when it makes angle 45 degree. So initially we are projecting here. When it makes angle 45 degree. This speed 20 meter per second is asking to calculate this. We'll resolve this into two components. One, ux, other will be uy, this will be vx, this will be vy. Ux will be u cos 60 degree. This should be equal to, or ux must be equal to vx. Vx will be how much? V cos 45 degree. U is how much? We don't know. Cos 60 1 by 2. V we know it. 20 meter per second. 1 by root 2. So u equal to 40 root 2 or 20 root 2. Next question we'll take it. This is again based on the electrostatics. Find the electric field intensity at the center of circle. You have to, he has given charges here. This charge will produce field here in this direction. Okay, fine. This charge will produce field in this direction. Negative charge. This charge will produce field in this direction. Okay, then this charge will produce field in this direction. So what will cancel out? The field produced by these two will cancel out, no? Will be like this and will be like this. So only the net field will be only due to these two. Okay, now we'll do one thing. Call E1, E2, E3, E4. E3 and E4 are equal. I'm showing the arrows. Only this E1 and E2 will added up. Now we'll write the equation now. E1 magnitude. E1 equal to E2 equal to KQ R square. The net field at O will be E1 plus E2 will be 2KQ R square. And it will make an angle 30 degrees. So resultant field EO bar will be EO cos 30 degree I cap. E naught sin 30 degree J cap. So minus 2KQ R square root 3 by 2 I cap 2KQ R square 1 by 2 J cap. This option will satisfy. A simple point charges concept is applied here. Next one, based on the thermal physics, heat transfer. As shown in the diagram, 6 rods of same geometry are connected. Same geometry, what do you mean by same geometry? Same length and same area of cross section. And maintained at temperatures, the temperatures at points A and B are. And their resultant thermal conductivity is given 3K, K, 3K and 3K. Now, which is at higher temperature? This is at higher temperature, so the heat current will flow here. A part of it will flow like this. Okay, then the remaining part of it will flow like this. Then how these two are? These two are series. Fine. Similarly, these two are series. and effective of this and this will be parallel. Directly will define the resistance of each rod. It will go to help us this one. Let me call the resistance of this is R. And let this be R. We know R equal to L by KA. R dash, I'll call it. Or write R1, better R1. R1 equal to, let it be R. R2. Let me call this as R2. These things as R2. This R2. This R1. What is R2 is equal to L by 3KA. This will become R by 3. So your entire thing will be R2. This will become R by 3. R by 3. R by 3. R. Temperature 100 degrees Celsius. 40 degrees Celsius. 2R by 3. R. So now he's asking to get these temperatures. A little bit calculation based only simple series parallel. You have to be careful with about the calculations. Now 2R and 2R by 3 parallel, effective that will replace. 2R into 2R into 2R by 3, 2R plus 2R by 3. 3 get cancelled, so here 4R, 2 3 just 6 will be 8R. So will become R by 2. This is A, this is B, and this is R, 40 degrees Celsius, 100 degrees Celsius. Now what is the heat current? Let H be the heat current. You have to do all this very fast, huh? I'm having slight headache, and I'm doing a little bit slowly here. Then what is H is equal to? H is equal to 100 minus 40 by R by 3 plus R by 2 plus R. 60 by 5R by 6, 5R by 6, 11R by 6. These two will be 5R by 6, 11R by 6. Then we can get the, here also same H, here also same H. I'll add one page extra. This calculation will be after this 100 minus this temperature. This should be equal to H into R by 3. 100 minus TA, H will be 360 by 11R by 3 into R by 3. This will cancel out. 100 minus TA, 360 by 11. One 110 minus 360 by 11. We'll get one temperature. This you have to calculate. Similarly, TB will be minus 40 equal to H into R. What is H? 360 by 3 will not cancel. 3 will be there. This will become 120. Calculations are very heavy calculations. 120. So 360 by 11R into R. 40 plus 360 by 11. We'll get the required options. When you solve it, we'll end up these two. This much is, it's lengthy paper, not tough, lengthy. I'm in 8th question only now, still. Next question is about the concave lens, concave convex lens. He has put some conditions, we'll read it. A convex lens of focal length 5 centimeter and a concave lens of focal length 4 are placed in contact. We have to use the formula. Lengthy, it's very lengthy here. Let me first case, convex lens in contact with the concave lens. Focal length f1, will take this is f1, this is f2. Magnification and object is kept where? 10 centimeter. Object is kept. Magnification and image will be formed and we have to calculate V1. Now what is the formula? 1 by f equal to 1 by f1 plus 1 by f2. f1 will be 1 by 5 plus 1 by 4. 20 by 9 centimeter. Image distance will calculate 1 by v1, 1 by u minus 10, go to 1 by f will be 9 by 20. v1 will get it as, I have to do calculation again. This will be 1 by 10. v1 will be 200 by 90 minus 20. 200, this will be 90 minus 20 will be 70. So 20 by 7, I got positive one. Then magnification, how much? Magnification, first magnification I'll write it. I have no place, I'll write it here only. 20 by 7 by 10 will be 10 by 7. Next situation, what is doing? Same. Now what he'll do, he will separate it. Lens is moved by 1 centimeter. Concave lens away from I know the magnification. Oh, it will become very lengthy. Twice we have to do the refraction. This object, as usual, u 10 centimeter. First we'll calculate image due to this. Final image, then magnification, then. Today I think my bad day for me. Lot of calculations I'm doing. Again, formula 1 by this v1, that v1 are different. Minus 1 by 10 equal to focal length f1 plus 5. For the first image will be formed by the, as this rays will come here, will undergo refraction, will undergo refraction further. Final image will come somewhere here. Now this will become 1 by v1 equal to 1 by 5 minus 1 by 10. v1 equal to 10 centimeters. Plus 10 will get it. And plus 10 centimeter. Okay, already this is one. Image I1 will be formed here. 9 centimeter from here. This I1 will become object for this. 1 by V2 minus of plus 9. Focal length of the concave lens is how much? It is 4 minus 4. 1 by V2 equal to 1 by 9 minus 1 by 4. V2 equal to 4 minus 9, 5, 9 4 is 36 minus 36 by 5 centimeter. Again we have to get the overall magnification. Magnification will call this lens as A, this as B. Magnification by A equal to how much? It will be V1 by U. V1 is how much? We got 10, this is 5, 2. Magnification by lens B will be V2 by, this is U2. V2 is how much? Minus 36 by 5, and this is U2 is 9, minus 4 by 5. So now what is M2? M2 will be, here only I'll do it. M2 will be MA into MB. MA is how much? 2. This is minus 4 by 5 minus 8 by 5. So M1 by M2. 10 by 7. M1 by M2. M1 10 by 7. Only we have to calculate this one. This will be 25 by 14. 25 by 28. Here 4. This will be, let me do this one. This will be 10. So this will become 5 by 4. 25 by 28. I have to check the calculation. Calculation will be 2. Concave lens is smoother. We are ending up like this. We are getting 25 by 28. 25 by 28. I think we don't have any simplification, no? Here. Option given 5 by 6. Will not end up anything. 5 by 6. I think it should have been 25 by 30 is telling. 7 is there. How 7 will. First case, focal length 1 by f1, 1 by f2, 1 by 5. Let me cross check. 1 by f. So this will be 5 4 20, 20 by 9. 1 by f equal to 20 by 9. Okay, fine. Minus 10. 90 minus all signs. This will be positive, this will be negative. V1 will be 20 by 7. It has to be 27. 7 will be there. We can't take it out 7. 7 will be there. The answer should be then next this will be 1 by V1. Then magnification will be 2. First case. Here magnification of this will become M2 will be MA will be 10 by 5 2. Then this will become object. This will become object. So this will be 9. 9 concave lens negative sign, virtual object positive. So 1 by 9, 36 by 5. MB will be 36 by 5 by object 5. So will be 4 by 5. Minus 8 by 5. M2 will be 8 by 5, 10 by 5. 25 by 28. There are no options. Should be. Okay, fine. There's a cross check. Some correction is there. Lengthy, very lengthy. Unnecessary for me trouble. Next one. Escape velocity from a planet of radius r and density rho is given as 10 km per second. Find the escape velocity from a planet of radius r by 10 and density rho. Something problem related to density. What is the escape velocity? Escape velocity formula. Any formula for escape velocity? The root of 2 gmr. Then density, what we can write? Mass by 4 by 3 pi r cube. This will adjust it. 2 gr rho 4 by 3 pi r cube. So this will become 8 g pi rho 3 r square. 8 by 3 g pi rho r square. Now you compare here. This is escape velocity 1. Escape velocity 2. 8 g pi 3 as it is. Density will be rho by 10 and the radius will be r by 10. I think will be 10 times of it. This is how much 10 is telling. R square, R square. Okay, this new escape velocity, no? This will be 8. Okay, this will be this all this will become 10. This will become 10. This will be 1 by 10 root 10. 100 root 10. Oh. Okay, fine. Next, 10th one. This is based on the meter bridge. Current electricity. Initially, null point was achieved at a distance of 40 centimeter when a resistance of 16 ohm is attached in parallel with R2. New balance point was achieved at 50 centimeter. Find the value of R1. Initially, 40 centimeter is there a balancing point. Okay, it's all about the Wheatstone network conditions. So here write L1 100 minus L1. So R1 by R2 is equal to L1 by 100 minus L1. Next, when a 16 ohm resistance is attached in parallel with R2, R1 by in parallel with R2, 16 R2 by 16 plus R2 is equal to new balancing length L2 100 minus L2. Okay, sir, what is the equation? How you are writing? We are writing the equation based on like this. L2, this R1, this R1, this is 16 ohm. Okay, fine. Now we'll get the R1 and R2 values. We know R1 by R2 values. From here, we can get the unknown things. What is L1? L1 is 40 centimeter. L2 is how much? 50 centimeter. So here R1 by R2 equal to 40 by 60. R1, 16 R2, 16 plus R2. L2 is 50. 50 by 100 minus 50. I think solving this will get R1 and R2. Based on the meter bridge, Wheatstone network current density. Logic gates, semiconductors. Logic gates here. So we directly start from here. It is telling now in the figure, LED glow for input of A, B, C, D. 0 is low potential and 1 is high. When the LED will glow, for that you have to check it. Then LED will glow only when these are at low inputs and the current should flow here. This will call it A cap, A bar, B bar. This will become A bar dot B bar. This will become C plus BD, C plus D whole complement. Now for LED to glow, this should be higher, this should be low. For this to be low, this should be 1, 1. Then this will become 1 plus 1 whole complement. Will be 1 complement, will be 0. Here we'll get 0. For this to be 1, this should be 1 and 1. For this to be 1, this should be 0 and 0. 0, 0, 1, 1. And even this is 0 also possible. If this is 0, 1 plus 0 will be 1 only. Okay, this option. Here 1 means 5 volt. Okay, fine. If 1 means 5 volt, it's telling 1 means high potential, 0 means low potential. Then the LED, what happen, will flow, will glow, a current I will be flowing. This is again got repeated. A closed tube filled with gas is rotating with omega along. Find the pressure at other end. This you can either call KTG or I'll call KTG, thermal physics. Gas or liquid, the idea will be same. We'll assume a small layer. Okay, fine. We'll assume a small layer. So what are the forces that will be acting on it, on this layer? Here pressure PS. Here pressure will be P plus dP into S and pseudo force dm omega square. Then the forces acting will be P plus dm omega square x. What is x? This one. Dm omega square x minus P plus dP into S. I'm doing this problem in rotating frame. Sir, what is the basic idea of all these things? Centrifugal force will act radially outward. Okay, fine, due to rotating that one. Pressure on this element will be P into S. Pressure from this side will be P plus dP into S. Now, PS and centrifugal force will be balanced by P plus dP into S. We'll simplify this one. PS will cancel out. Dm omega square x equal to dP into S. Dm or dP equal to dm omega square x by S. Dm, what you can write, rho, area of cross section, S it is, omega square x pressure at x equal to 0, pressure is Pa. At a distance x, let the pressure be P. Okay, we got the expression for pressure. What is a rho? Rho again, what we can write it as? Density we have to replace, no? Density of the gas. I'll do one thing. One more step is there. Before going for integration, because we have to. There's no density, no, in the equation. Not available. So therefore, what we do? Rho you can write it as density equal to Pm by RT omega square x dx. So this will become dP by P is equal to m omega square RT x dx. Now at x equal to 0, pressure is Pa. At a distance x, let pressure be this one. At A is Pa. Find the pressure at the other end B. At other end B means what is the length of the tube? Length of the tube is giving L. This will become log of log of P by PA m omega square L square by 2RT. Very tough, huh? We'll take the next one. For an ideal gas, in a reversible process, volume becomes 8 times and current becomes 1/4 times the initial value. Identify the gas. And delta Q0 means adiabatic process. And it's a thermodynamics. Huh? So what is the formula we should use? T1 V1 gamma minus 1 equal to T2 V2 gamma minus 1. Identify the gas. We have to calculate the gamma. V1 by V2 gamma minus 1 equal to T2 by T1. Volume becomes 8 times 8V2. And the temperature becomes 1 by 4 times. One by 8 gamma minus 1 equal to 1 by 4. So 8 to power of gamma minus 1 equal to 4. So this will become 2 cube two square. So this will be further 2 to power of 3 gamma equal to 2 to power of 5. Gamma equal to 5 by 3. Gamma equal to 5 by 3 means it's a monoatomic gas. Monoatomic gas is what? Helium here. 14th one. Based on the electrostatics point charges. So what is the question? The question is, a simple pendulum with bob of mass m carrying charge q is in equilibrium in presence of horizontal electric field. The tension in the thread. Now in the diagram only try to analyze here. What are the forces acting? Will be QE, here mg, and here tension. This is the bob. This one is a bob. Or bob, or you can call it as a charge particle. Then this will become theta. It's asking directly the tension. Tension should be equal to mg square plus electrostatic force QE square. Very easier. Some questions are very easier. Detector D moves from A to B and observe the frequencies are differing by 10 Hz. Source is emitting frequency F0 actual. Speed of detector is 35 times the speed of sound, then F0. Actual frequency is asking. So when it is here, I think there's a Doppler effect. Waves and sound. This is the source. Observer is here. It's moving. V0. This is theta. So the waves here, they'll be emitted with a frequency F0, will be received with frequency F1. What is F1 is equal to? F1 equal to F0 V minus V0 cos theta by V. Same thing when the source is, when the observer is here. V0 will be here. And the waves will be emitted at frequency F0, will be received at frequency F2. Here at frequency F1. then this will become theta. Then F2 will be F0 B observer approaching source, positive in this case. Let me explain the concept. If observer approaches the source, then what you have to do? Component of velocity along the source, V0 cos theta plus V0 cos theta will come. Then here the observer receding away, moving away, then component of velocity along line joining source and detector will be V0 cos theta as moving away. So therefore you have to write it as V0 cos theta by V. Speed of detector is 35 times less than this one. So what is V0? V by 35. So this F1 minus F2 is equal to how much? 10. I think we can solve this. All things will cancel out. We'll get F0 V0 cos theta by V equal to 10. What is the cos theta? You can determine from here. Cos theta 1, theta 1, theta 2. Okay, I didn't see it. This is theta 1, theta 2, theta 2. This is theta 1. Calculations will be like this. I didn't see this. 160, 90. They are different length, no? 160. This is 120. We have to calculate cos theta 1. F1 minus F2. So this will become F0 V0 cos theta 1 by V. Minus of minus plus F0 V0 by V cos theta to 10. So what you can do now? You can take F0 V0 V outside cos theta 1 cos theta 1 you can find out from here. This is R1, this is R2. What is cos theta 1? Will be 160 by R1. What is cos theta 2? 90 by R2. Lendia. You have to work out. I am not student. In exam you are supposed to work out. More or Doppler effect, it should be out of syllabus. I don't know. I should not have asked it. But okay, fine. This is the basic approach. You have to do calculation. I don't know what will be the answer. 350 what I have. Verify it. I am still 16th question only. No. A ray parallel to x-axis. The x-coordinate where the ray cuts the x-axis. Okay, what is the thing is? This is the incident ray. I'll help you with the diagram. This is the incident ray. Okay, fine. What is the boundary? This is the boundary. Oh, okay, able to analyze now. This is a boundary. Oh, fine, leave it. Then this medium is here. The medium on either side. This here, and this is 1.5. Where do you tell cut is telling? Is asking this distance. Or V, you can call it. So mu V minus 1. This is A, no? By infinity. Mu minus 1. Radius of curvature plus 50. Ray optics. Refraction at curved surface. mu is 1.5, this will be 100. V equal to 150 centimeter, 1.5 meter. 17th one, based on the EM waves, equal to 20 sine, okay, something is given, propagating in a non-magnetic material, dielectric constant of this. We'll do one thing, we'll calculate the speed of the wave. Any formula, speed of the coefficient of t by coefficient of x. Coefficient of t 10 to power of 6, coefficient of x 2 by 300. 300 by 2 into 10 to power of 6. 150 into 10 to power of 6. This should be equal to c by under root of mu r. Epsilon r, sorry. C is 3 into 10 to power of 8 root of epsilon r 150 into 10 to power of 6. 10 to power of 2, or say like a 300 epsilon r equal to 150, or epsilon r equal to 4. This is a formula. Hope you remember this. Non-magnetic medium. 18th one. Match the column with the column 2. 1 mole of monoatomic ideal gas undergo polytropic process with delta T, find delta U. What is the type of process? It is polytropic process. Polytropic process P with delta T. Find delta U. We'll calculate first the heat, then work done, we know the formula. I think this is also again very lengthy. First option A, polytropic process. This is equal to constant. Work done equal to nr delta T by 1 minus 1 by 2. Okay, then this will be Cv plus R into 1 minus 1 by 2. Then we'll get dq equal to nc dt. N equal to 1 mole. Okay, this will become R into 320. This will become 3 by 2. This will become Cv, monoatomic gas, 3R by 2. Plus this will be 2R by 3. 9, 11R by 6. Molar capacity. Substituting this, 11R by 6. Change in temperature, 320. We'll get dq. Then dq equal to du plus w. Enjoy the calculation. This for A. Find the heat supplied to the 2 moles of gas having heat capacity. For option B, it's very simple. dq equal to nc dt. Number of moles 2. C is 5R by 2. Temperature 130. Find the delta U. Okay, this is about. Next C. Find the delta U for 1 mole of diatomic gas for delta T is equal to N R delta T gamma minus 1. Gamma for diatomic gas 7 by 5. Substitute and solve, we'll get this one. Just it is based on thermodynamics, thermal physics. Okay. Next, based on the experimental physics, units and dimensions. Spring constant, I think everyone should able to do this option given. Spring constant, first one. Spring constant will be K into X. K will be F by X. F will be M1, L1, T minus 2, L1. Will be M1, L0, T minus 2. 1 will be 3, no? Can you work out all this? I'll go for other things. Like this thermal conductivity. What is the thermal conductivity? K, that one. Let's this one. This is based on the electromagnetic induction motional EMF. A rod of mass m and length L is released on a rail placed in uniform magnetic B. What will be the terminal velocity? Oh, fine. Very good question. Huh? B bar into the plane. What are the forces that will be acting on the rod? Mg. What is a rod? This part is a rod. Huh? Okay, able to get this. And this is a rail. You don't bother this one. Okay, able to analyze now. What are the other forces that will be acting? BIL force. Okay, fine. Here magnetic field into the plane. So it will move with a constant velocity when mg equal to BIL. What will be the terminal velocity is asking. What is I is equal to E by R BL terminal velocity R. mg B I will be BL VT by R into L. So terminal velocity will be mgr by B square L square. So why you are equating forces? Because terminal means after a long time at t equal to infinity. Tough fight is. Next one. Liquid pressure is only exerted on the solids in contact and is exerted in between the layers of liquid. Sufficient exert due to difference in potential of molecule in bulk of liquid and at surface. Both are correct statement. Theoretical, just information based. I don't have anything to explain further. Just information based. Problem based on surface tension. Next, photoelectric effect. A photon is incident on a particle of mass m. What should be the frequency of photon so that particle of mass m breaks into 4 alpha particle? What is the basic idea of this? Photon incident on particle, having the particle should be broken into 4 parts. And particle is having AMU. Mass of alpha particle. 13 point, okay, what is giving alpha particle? 15. It will break up into 4 alpha particles. Okay, fine. This will be the energy carried. The energy supplied by the particle should be equal to mass of alpha particle into mass of particle into c square. 4. This will be 4.004 AMU. This will be 15.356 AMU. C square. 1 AMU is not, we'll write it now. 4 into 4.004. 1 AMU is given, not given, we'll assume 931 mega electron volt into C square. This is everything we have to solve it. Minus mega electron volt, that also we have to cancel out. This will be 10 to the power of 6 into 1.6 into 10 to the power of minus 9. H value will be equal to HF. H value will be 6.6 into 10 to the power of minus 24 into F. Now we have to solve this one. Lot of calculations. Enjoy. We'll get this answer. 23rd, this is based on the gravitation. If initial force on m0 equal to f0, when position of 4m and 3m are interchanged, force become f dash, is asking that one. The ratio of that forces. What are the gravitation forces that will act here? Initially, this 4m and 2m, the resultant will be in this direction. And the resultant will be in this direction. Sir, how you are telling? Now this is 4m, this is 2m. This will exert force 2f and this will be f. The resultant will be f, no? Similarly here, and 4m minus 2m. And similarly here m0, here m0 3m. The resultant will be 3m minus m will be 2m. Here we'll write down this force. This is F1, F2. And they'll make equal angle. And theta will be 45 degrees. F1 equal to F2 how much? G 2m m0 L by root 2 whole square. This length will be how much? L by root 2, half of the diagonal. So this will become 4g m m0 L square. F1, F2. The resultant of this will be F0 is telling. What is F0? F1 cos theta plus F2 cos theta. Theta equal 45. 2F1 cos theta. 2F1 will be 4g m m0 L square 1 by root 2. Okay, this is a thing. Now 4m and 3m are interchanged. 3m, 4m, m0, m. Call F3, this F4. Now again, 3m and 2m. Resultant will be m m0. 4m minus m. Resultant will be 3m. This angle will be same theta. So here resultant force will be F dash. What is F dash? F dash equal to F3 cos theta plus F4 cos theta. F3 will be 2 m only. So why you are writing m? See, 3m m naught. Here 2m m naught. The resultant of these two will be just only gm m naught. Hope you are able to understand the logic here. G m m naught L by 2 whole square cos theta 1 by root 2 plus similarly the resultant of these two. M m naught will act here. M naught m will act like this. Then m naught 4m will act here. The resultant will become 3. 3 G m m naught L by root 2 cos theta will be 1 by root 2. Now you solve it and work out the calculations. Okay, we'll come this. Lengthy, this also lengthy. 24 based on atoms. The energy required to excite electron from the first Bohr orbit of hydrogen atom to second Bohr orbit. Energy in the first Bohr orbit, how much? Minus 13.6 electron volt. Energy in the second Bohr orbit, how much? Minus 3.4 electron volt. How much of energy needed? The difference of these two, 10.2 electron volt. E2 minus E1. Then this should be equal to in electron volt is there, so 10.2 into 1.6 into 10 to the power of minus 19. This will become joule. We'll get this. There's one more is there. Huh? There's a glass sphere. Let me read the question. There's a glass sphere of refractness 1.5 on which a parallel beam of light falls. Find the distance of final converging point of the final emergent ray from the center of the sphere. Okay, this is about the based on the ray will come like this. Will undergo refraction. Will again undergo refraction. This will be mu, this is A, this is R. This will be P1, this will be P2. At P1 we'll write the formula. Mu P1 I1. This will be 1. This is air, no? Infinity. Mu minus 1 plus R. So this will be 3 by 2 P1 I1 equal to 1 by 2R. P1 I1 equal to 3R. So where the ray what will happen? I don't know this option. Oh, all things gone. Huh? How to erase that line? Last one. Okay, this it will come like this. Will be 3R from here. This is 2R and this is R. ray will come like this. Again we'll undergo refraction here. Lot of patience needed this paper. Huh? Again they're moving denser to rarer, so the ray what will happen will bend finally at this point. He's asking about this. So here this is I1. We'll apply this one. Again the ray is moving in the rarer medium at P2. Towards right will be positive. So P2 I2 minus mu. This will become R plus R. 1 minus mu minus R. 1 by P2 I2. This will become 3 by 2R. 1 by 2R. 1 by P2 I2 equal to 3 by 2R plus 1 by 2R. 4 by 2R by 4. R by 2. R is how much? 50. Will be 25 centimeter. 25 centimeter from this one. Huh? From the center of the sphere will be 50. This length will be P2I2, 25. So total will be 75. Paper lengthy. So this again ray optics. Very lengthy, difficult. Clean bold. Huh? Okay, students, will end up the class. Second shift I'll upload. Let me take rest. I'm very tired from this paper.